Well, welcome everyone. This is Eli Sagor with the Sustainable Forest Education Cooperative. We are pleased to be here with the third in our series, the second, who can count that high? The second in our webinar series for 2016. We are really happy to be offering the webinars again this year in partnership with the University of Minnesota Extension. And the topic today is Practical Silviculture for Non-Foresters, an Introduction. As a reminder, you can get recordings of all of our webinars from the SFEC website. You can also get links to those recordings from My Minnesota Woods. And if you ever have any trouble accessing any of those, please just drop us a line. We'll be happy to help you out. The talk today is kind of serving a dual purpose, where it I hope will be a useful standalone presentation, but it's also setting up a workshop that we're going to be doing later next month. We're doing a day-long workshop here at the Clearcutting Forestry Center with the same title, Practical Silviculture for Non-Foresters. The three instructors for that workshop are myself, Marcella Windmuller-Campione, who's the silviculturist in the Department of Forest Resources at the University of Minnesota, and Kyle Gill. Kyle is the forest manager here at the Clearcutting Forestry Center, and the three of us all work together to pull this presentation together. I also want to acknowledge Grant Domke. A couple of the slides that appear in this presentation are derived from work that Grant shared during some workshops that we did together a few years ago. So first, what are we going to cover? We have about an hour today. I plan to wrap up by 1 o'clock. I'm going to start with the basics. What are some of the common definitions? What is silviculture? What are the common silviculture systems? And then what are, briefly, some practical applications in Minnesota? Silviculture is a pretty complex topic. There's no way that we could cover all of the details in an hour, and I'm not going to try to do that. What I am going to try to do is give you all kind of a flavor for what silviculture is all about. So the basic theory of silviculture, the definitions and the context and the thinking that underlie what we think of as silvicultural systems and techniques. And then briefly kind of how those techniques are deployed in Minnesota to manage common species. And again, we'll go much deeper into all of this, mostly in the field during the workshop in March in Clearcutting. And just one more word before I start. I'm assuming an audience of mostly natural resource managers, so I'm guessing that many of you listening are familiar with basic ecological principles and the basics of land management, perhaps with a focus in an area other than forest management, but nonetheless with that level of knowledge. So, the basics. Let's start with what is silviculture. The definition most often used for silviculture is right here on the screen. I'll give you a moment to read it. So the two words that most of us focus on when we're thinking about really defining silviculture are art and science. What I'm going to be talking about today are a series of tools, a series of ways of thinking, a series of techniques that we can use in the woods that can be deployed in a wide variety of ways. We're going to first go through kind of the basic systems, and then we're going to talk about how those can be tweaked and modified and changed around to meet the unique attributes of the system you're trying to manage, to meet the unique objectives and trade-offs and balance points between all of the things that form the kind of the second half of this, the diverse needs and values of landowners on an ongoing basis. So applied forest ecology is, so we can do the art and science of managing all of these things. The short definition, or what silviculture really is applied ecology. So silviculture is informed by decades of research into ecosystem function, obviously focused on forested ecosystems. These are highly complex systems. And when we begin to think about applying what we know about the ecology of these systems, it happens with a lot of understanding of silvics. The silvics are the individual attributes of certain species. So how much moisture does a certain species need? How much light does it need at various life stages? That sometimes changes through the life of tree species. What are we trying to manage for in the near term and in the long term? Which are the outputs that we want to achieve. You know, we're applying ecology, but we're really doing that through the lens of human values. And so we're talking about, you know, what are the human values that we want to achieve? What are the outcomes we want to achieve from these treatments in terms of those human values? So again, this ecology and our silvicultural treatments are generally influenced by social and economic considerations. We're applying the ecology side to get us to certain social and economic outcomes. Those are often, I mean, in a very simplified list, those include landowner objectives. Different private landowners or public landowners manage their land with a different set of objectives. Costs, we might have great ideas for things we'd like to do in the woods, but if it's not economical, if loggers won't bid on it, if we can't pay the bills to do that, we can't do it. So cost and operational concerns likewise go into that mix. Some of the silvicultural systems that I'm going to be talking about are pretty simple for a logging operator to implement. Others are not at all, or for foresters to set up and mark the timber and so on. Others it can be quite complex. And so that complexity and operational considerations can be an issue. And along with the high cost, as I said before, is the marketability. Will anyone bid when we offer timber for sale? If not, we're going to have a high cost of implementing these treatments. And so these are all big factors as we plan our silvicultural treatments. So again, a set of tools to be deployed creatively. And I want to introduce a new term here, this idea of growing space, which in, you know, if we think about silviculture, I kind of like this idea. It's growing space is central to silvicultural thinking about how we're managing and controlling the availability of growing space. Growing space is a pretty simple term. It's pretty, it can be interpreted in a few different ways. It doesn't literally mean growing space in the sense of the amount of soil in a pot for a house plant. Different species might find different available growing spaces in the same area, in the same stand. Species that are highly shade tolerant, that is, they can thrive under dense shade, might find growing space where species like aspen or red pine that are shade intolerant would simply not have enough room to grow. So we use silviculture to manage and control the availability of growing space to hopefully favor the species that we want to see coming back or thriving, and to disfavor the ones that we don't. This idea of desired future condition weighs obviously very prominently into silvicultural thinking. So we know what we have now based on inventory data, based on walking the stand and looking around. Before we can come up with a silviculture prescription, we have to know where we want to go or what that desired future condition ought to be. And I have a long list of questions here that can weigh into that. I hope that however you're viewing this, these are big enough to read, and I'll give you a moment to read them. This desired future condition is sometimes where things, well, the first spot where things kind of get interesting when we're thinking about silviculture prescriptions, because as I said before, we're managing human values. We're using our knowledge of ecology and a few kind of ecosystem management tools and techniques to get from here to there, but we have to decide where there is. And sometimes there are competing views on the answers to these questions. What species do I want here? Certain wildlife species and other species might favor certain kinds of mass-producing trees, or trees that provide more thermal cover, or trees that can be food in a variety of ways. We might want those species on site, or we might not. We might want them and feel that that's a top priority, or we might kind of like to have them, but we're not going to reorient our management around that. They're very different, you know, again, different people have different views and different priorities at the site and landscape level and so on. How do I want those trees to be arranged vertically and horizontally? So what kind of structure do we want to see within that forest, within that stand? Do I want to be able to harvest trees in the future? If so, I'm going to have to think a little bit about what trees I view as marketable, but how quickly they're going to grow, about what I can do to favor those things. In addition to simply, do I want to have wildlife here, we need to think about what kinds and at what stages of stand development. And really that idea of things changing over time applies to many of these questions. So do I want wildlife early in the stand's life? For example, am I managing to produce browse for moose? We hear a lot about, we did a webinar last November on that topic. How can we produce more young aspen and other kinds of brush up on the arrowhead of northeast Minnesota to favor moose? Well, that's very different from wanting to manage for say, thermal cover for moose or other species several decades into the stand's life. So at what stages do we want to produce these different things? And of course, are there special considerations that we should make to encourage the use of this stand as habitat, and for what species, in what ways? So a silvicultural prescription, we've agreed on what we have, we've agreed on what we want that desired future condition to be. Now how do we get there? And the prescription is the place, the document, where we capture all of that together. We write down how we're going to get from point A to point B. So we have to have goals for that stand. We have to have objectives, desired future conditions, and then I'm going to talk next in the next section about the different tools that we're going to deploy in order to get us from here to there. And I've already talked about this, so I'll just mention it briefly, but silviculture, and I do intentionally repeat this because this is really at the center of a lot of what forest managers are doing. We have to be continually making trade-offs. So I put kind of the ideal treatment in quotes there. There might be lots of things that we'd really like to do in terms of designing the most elegant, perfect silvicultural treatment, but we can't for a whole variety of reasons. Just a few of those broad reasons, again, are listed here. And I've already talked about those reasons, but trade-offs are really central to managing forests and using silviculture. So the next section is going to go into silvicultural systems. I'm going to pause here. I can't see questions as they come in, so Julie's shaking her head. If anyone out there does have any questions, I'll pause for a moment to have you type those in, and then I'll move on. I'm used to introducing someone else rather than taking the floor myself, and it occurs to me that I forgot to say a few things that I usually say. One is related to questions. So if you're in a broadcast site, go ahead. If you have a question, just make that question known to the broadcast site host. If you're watching from your own computer, please use the chat pod to type those in. If you're watching full screen, you can tug that down from the top and type a question in, and I will be pausing throughout the presentation to take questions. All right, silvicultural systems. So let's now dive into the toolbox. Is doing nothing a silvicultural treatment? Well, we'll get there. You can ask that question again, Luke, later, or we'll keep that in our back pocket and try to come back to that. So first, what is a silvicultural treatment? We often think, several of the silvicultural systems have share names with harvest treatments or harvest systems, and so I want to clearly differentiate those. Silvicultural treatment is more than a harvesting system. The silvicultural system or treatment, not a treatment, silvicultural system applies to the whole rotation. It includes a plan for regeneration, a plan for tending or intermediate treatments, and a plan for harvest, which reinitiates the regeneration and the whole cycle. A harvesting system, for example, clearcutting or a clear cut, applies only to the harvest. And so throughout, we're going to be talking about all of those steps, and I don't have time to go deep on any of these systems, but I want you to keep in mind that we're not just talking about how do we harvest the trees, what's the pattern of tree removal, but we're talking about how do we regenerate the stand? Of course, that's related to the harvest pattern. How do we tend or take care of those trees as they're growing? And then how do we implement that final harvest? So if we think about harvest or regeneration methods, we can think about a few different variables here. We have natural and artificial regeneration up at the top. Natural regeneration relies on seed, either dropped from residual trees or in the soil seed bank or provided in another way. Artificial regeneration is regeneration brought in from off-site, so seeding, direct seeding, planting, and so on. So we have natural versus artificial regeneration. And for the bulk of this section, I'll be talking about what we see down below, harvest methods, selection. I'll talk about single tree and group selection, shelterwood, seed tree, and clear cutting. So it's useful to think about these silvicultural systems along a spectrum of harvest intensity or disturbance intensity. On the left side of the screen here, we see, a relatively moderate disturbance, removing just a few dispersed trees. Over on the right side, at the other extreme end of the spectrum, we have removing all vegetation. The silvicultural systems that more or less correspond to those different ends of the spectrum are single tree selection on the one hand, clear cutting on the other. And then there are a variety of treatments that can be deployed kind of in the middle. In fact, just about everything applies somewhere in the middle here. Removing groups of trees is a system we call group selection. Removing trees more or less evenly throughout the stand could be called a thinning, depending on the purpose and intent of that treatment, or if it's intended to create new regeneration, it would be called a shelterwood treatment. And then there are a variety of, most intermediate treatments fall somewhere, except for the far right end of the spectrum, they fall somewhere in between. I'm also going to talk about the seed tree system, which is pretty close to clear cutting, so kind of somewhere in between shelterwood and clear cutting. So let's get into the first of those, the selection system. We're going to talk first about single tree and then group selection. Now, I haven't talked yet about uneven-aged or even-aged silvicultural systems. Those terms refer to the age distribution of the stand after treatment. So a treatment or a silvicultural system that's even-aged would produce trees of more or less the same age. An uneven-aged system like the selection system produces a stand with a wide variety of ages. We can also have two-aged systems, and I'll refer to those briefly just a little bit later. So under the selection system, the outcome is basically new cohorts, either as individual trees or as small groups of trees. And because we're creating very small gaps, we tend to have regeneration really only of shade-tolerant species, or certainly predominantly of shade-tolerant species. Again, species that can thrive and grow under a low-light environment. So how do we do it? Basically, single tree selection. We remove single trees or small groups, and then we might do some tending to continuously improve the stand. Depending on your objectives, you could take or leave a variety of different species or tree forms, and so on. And I've got a couple of figures here to sort of illustrate this. You'll see a number of figures throughout the talk from the Wisconsin DNR Silviculture Guide. I think these depict things really nicely. So this is just kind of a before and after. Here's single tree selection before any treatment. Here's what it might look like after. If we toggle back and forth a couple of times, you can see, as I said earlier, it's a relatively low intensity disturbance, one or two few trees removed here and there throughout the stand. And over a long period of time, there's this sort of ideal notion, and we can never really get there in the real world. It's just not practically feasible. But if we do single tree selection, if we apply that system over a very long time, we would end up with a perfectly regulated stand with the mix of age classes roughly as you see here. These are, a 15-year harvest interval, and we get trees of 15 years of age, 30, 60, 45, 75, 90. And while, again, we never really get to this stage practically, this is the type of mix that we ultimately would end up with under a single tree selection system. And I could go into a bit more detail, but just want to convey the basics here. So what about practical applications of the single tree selection system? It can be really time-consuming to set it up properly. The process of inventorying and marking timber under this system can be extremely complex. Again, especially if you really try to adhere closely to the letter of the system. It can be really challenging operationally. The logger would continually be trying to move around established regeneration, trees of a variety of sizes, to get to just a tree here and a tree there. So relatively high harvest cost and complexity. Single tree selection is primarily, at least in this part of the world, used in hardwood systems. We'll talk a little bit more about that. Oh, I guess my examples come a bit later. So that's single tree selection. Let's move now to group selection. This is moving us just one notch to the right on our spectrum of harvest intensity. It's also an uneven age system that often favors shade-tolerant species. That depends on the patch size or the gap size. Taking out larger gaps is going to create a larger highlight environment. I'll have a figure showing that in a moment. Small gaps is going to more closely replicate single tree selection. Similar idea, except groups of trees rather than single trees. And basically, this system creates gaps of trees with a variety of ages within an intact matrix. And that is to say, the areas between the gaps are generally not treated, at least in the pure kind of group selection approach. So if you look around on Google Maps a little bit, I think this picture is taken from the Cutfoot Experimental Forest. This is an example of what this treatment might look like from the air. So a series of small gaps distributed throughout a larger, relatively intact matrix. And I said before that depending on the gap size, you can end up with either larger or smaller areas of kind of higher and lower light. And what I meant to depict, I'll use my mouse here so that the folks online can see it, is that down, the gap on the south side of this gap is mostly shaded. You can see shade here. This picture was taken to simulate or to indicate the sun's angle in June. And you can see that there's shade on the southern rim of that gap. There's really no shade at all up on the northern rim. And you get, as the sun moves throughout the day, you get a different light environment across that gap. So again, a larger gap is going to favor trees that are shade intolerant. Smaller gap is going to be shadier and is going to favor trees that are more shade tolerant. A lot of our silviculture is designed to mimic natural disturbance. I've got a few pictures in here showing kind of the natural version of the type of disturbance that these systems are meant to emulate. It's a wind-created small gap, picture shared by John Drimmel. This was from the storm that hit west of Grand Rapids a few years back. So what about practical applications? I mean, does anyone do this? It's a nice idea, but does it happen on the ground? And the fact is, it doesn't happen a ton on the ground, at least here in Minnesota. It's not common. I'll show some data dating to 2008 later in the talk to give an idea of how prevalent each of these systems is here in Minnesota. But it is becoming a little bit more common. And the picture that you see here was taken, this is another Google Earth image that was taken of Blandon Paper Company land, and they're using an approach called the string of pearls approach. I hope you can see the little connections. You can see small alleys going from group to group. This is technically a slightly different approach from a pure group selection approach. Their objective in creating this treatment was to take an aspen stand and mix it up a little bit. Blandon is well known around here for favoring a mixed wood approach on the right kinds of sites, mixing spruce in with aspen, and they tried this in order to do that. The Aitkin County Land Department also is using this string of pearls approach, but for a slightly different reason. They do this sometimes in kind of low-value hardwood stands as an operationally pretty efficient way to get these stands marked and to kind of start over with at least gaps and a new cohort across part of the stand. They just mark the center tree of each gap. Loggers have GPS equipment within the cab, and they can manage the distance from that gap. So it's relatively quick and easy to set up as well as to harvest. So not common. It's not done a lot, but we do see a little bit more interest and application of group selection here in Minnesota in the last few years. It's 25 after 12. We're kind of coming up to halfway through our time. So again, I'm happy to pause for questions at any time, but I'm going to keep going. Shelterwood Method. Shelterwood is an even-aged system. So the two systems I've talked about before are uneven-aged systems. They create new age cohorts throughout an intact stand. The Shelterwood method is designed to regenerate an even-aged stand in contrast with those others. So how do we do it? We conduct a partial harvest. The density and number and arrangement of the residual trees depends on the species that we're trying to regenerate. But under this system, you can think of the residual trees as a shelter designed to do two things. One, to provide the right light and moisture environment to favor the desired species for regeneration. And two, and I have with a question mark here, to provide seed for the favored advanced regeneration. Advanced regeneration, that term refers to regeneration that's established before the final harvest. So in advance of the final harvest. So natural regeneration that's on site before that final harvest. So we leave a partial stand, we conduct a partial harvest, leaving trees at the right density, and if we are relying on these trees to drop seed, then we might want to leave trees with good form and other positive genetic attributes to contribute that seed for the next stand. We wait until that advanced regeneration is established, usually 5 to 10 years. Then we go in and remove the overwood or remove the canopy to release that advanced regeneration. So a multi-step process. Here are some more of these Wisconsin DNR images. This depicts a hardwood stand, mature hardwood stand before any treatment at all. First cut of the shelter wood removes some of the trees, leaving an intact group of residual trees to provide the right light environment and seed. And you can also underplant. So if you underplant, if you use artificial regeneration under the Shelterwood system, then you can think of those residual trees as just kind of a nurse crop. All they're doing really is providing that right light and moisture environment. So we could use either natural or artificial regeneration under this system. So again, intact stand shown here. After the first cut, this is what we've got. 5 years later, give or take, if everything goes well, we have a nice crop of advanced regeneration established in the understory. Once that advanced regeneration is well enough established, we go in and remove the overstory or the overwood. And the purpose of that removal, of course, is to provide, once we've got that advanced regeneration established and high enough to clear any major vegetative competition, we release it. We let it grow, leave it free to grow. And of course, as I said before, there are a lot of variations on this system. Some of that residual stand could be left intact if a more complex stand structure was part of our desired future condition or not. So another picture by John Drimmel here of a wind-created shelter wood, something sort of simulating that. And we might hope that there wouldn't be a second windstorm to take down the overstory in 5 to 10 years, but this at least emulates, or the first cut of the shelter wood somewhat emulates a disturbance here that it takes out some of that canopy, but not all. Okay, so practical applications. Does anyone do this, and when and where? It's relatively uncommon. It is done extensively in a few places. Tom Kroll at the St. John's University Arboretum has implemented a number of shelterwood treatments. The Arboretum is heavily dominated by oak. And Tom, and I'll show a picture or two here in a moment of some of those treatments. They use it a lot, and a lot of folks managing for oaks in other parts of the country, oaks and other kind of mid-tolerant species use the Shelterwood system. And I didn't say this before. If you think about it, it's fairly clear, but Shelterwood, so I said before, the selection systems really favor shade-tolerant species. We have small gaps, a lot of shade. Shelterwood system really favors kind of mid-tolerant species. So not the most shade-tolerant. They might be outcompeted by the mid-tolerant species. Not the most shade-intolerant or light-demanding, because there is still a pretty heavy mosaic of shade and sun. But mid-tolerant species, white pine can succeed well under the Shelterwood system. A variety of oaks and other species are well suited to this system as well. The part of the, one thing constraining broader implementation of Shelterwood, I mean, there are a few things. One is it requires repeated entries. You have to go back a few years later, whereas with a clear cut, you go in once and you do your site prep and establishment. If needed, you walk away. Shelterwood requires repeated entries, and there's some uncertainty. Sometimes the regeneration happens as you hope it will, and other times it doesn't, and so it can be slightly less certain, and uncertainty can be difficult to manage at times, particularly when we're managing budgets and human resources and so on to get these treatments done. This is a picture from St. Louis County of a Shelterwood treatment applied in a white pine stand and designed to favor white pine regeneration. And I mentioned Tom Kroll and the St. John's University Arboretum. This picture I think was taken in 2007, 2008. I haven't been back to revisit this stand since then, and I hope to get back there before too long. But you can see the kind of matrix of residual trees that are designed to create that mix of sun and shade, relatively evenly distributed across the stand. And you can also see in this case, they do some deer management, but they have a very high deer population, and the tree shelters that you see in the foreground and elsewhere there are designed to protect at least some of that oak regeneration from deer. So that was the Shelterwood method, and go ahead, Julie.
Regarding Shelterwood, how do you protect the regen from damage at the last Shelterwood harvest?
Yeah, that's a common question, and I alluded to that briefly when I mentioned single tree selection, but I didn't come back to it. That's a risk. That's a downside associated with this system, and there's no way to completely avoid it. There's going to be some residual damage and some damage to advanced regeneration. Hopefully with a good plan for that stand and a well-designed skid trail network and so on, you can minimize that. But there will be some damage to the stand. I'll mention briefly at the end Minnesota's forest management guidelines, and there are some good guidelines that can help, with good suggestions and ideas to minimize the impact of the skid trail network and harvest-related damage. But it's impossible to completely avoid it. So good question, and that too may be one reason why we don't see this done more often. Any other questions, or was that the only one?
There's another general question.
Great.
Is there a source on the web where I can learn what conditions different animal species need?
Oh my goodness. The question was, is there somewhere online where you can find basically habitat needs and for different wildlife species? There are a lot of wildlife species. Some of that information, I know the DNR, Division of Fisheries and Wildlife, has good information about the wildlife habitat needs of Minnesota native wildlife species. Trying to think if any of that is on the My Minnesota Woods website that Extension manages. There might be some wildlife information there. I think I would go first to the Minnesota DNR Division of Fisheries and Wildlife and see what you could find there. Is that it? Thank you. Okay, so we talked about single tree selection. We talked about group selection. We talked about Shelterwood. We're still moving along our kind of spectrum of intensity, treatment intensity, harvest intensity, over to the seed tree method. So under the seed tree method, we start with, this is another even-age system. This is one that favors shade-intolerant species. So what we're going to do is we're going to harvest all but a few large trees or a few wind-firm trees per acre of the desired species to provide seed for natural regeneration. Generally, seed trees are evenly distributed across the stand. We're not using the seed trees to alter the light environment. We want them widely enough spaced that basically full sunlight is available to regeneration or pretty close to that, but dense enough, numerous enough that we get an adequate seed fall because the seed tree system relies on seed drop from those residual trees that are left standing during the initial treatment. Like the Shelterwood treatment, often seed trees are harvested. Sometimes they're harvested once the regeneration is established. Sometimes they're not. That's an option. Certainly, as the question earlier alluded to, there can be damage to regeneration by entering a stand after regeneration is established, and that's certainly true of this system as well. If those seed trees are retained, we end up with a more complex structure. We often hear about the benefits of residual trees for raptors. They provide perch locations and other things, and so those can be either removed, leaving a two-aged stand, or removed. I think I said that right. So back to our diagrams here, the seed tree approach. This is kind of a before picture. Here's an after picture that looks remarkably similar to another photo I'll show you here in a moment. And you can see some regeneration established there. That's what happens if everything goes according to plan. And again, you could come in and remove those seed trees if you like, or not, depending on the prescription and the desired future condition. Seed tree system is designed to emulate a more intense wind disturbance, or in some cases a fire that leaves just a few remaining healthy trees on the landscape. Creates a very open light environment, favoring shade-intolerant species, light-demanding species. Practical applications, the seed tree approach is really rare. It's basically hardly ever done here in Minnesota. Those of you who have been to the Clearcutting Forestry Center have perhaps visited one. We often go and take a look at a red pine seed tree treatment that's just well under a mile here from the Clearcutting Forestry Center buildings. Well, why is it so rare? There are a couple of reasons, I think. There's anytime you're relying on natural regeneration without having it on site already as advanced regeneration, there's uncertainty about how that regeneration is going to go. Are you going to have adequate regeneration? Are you going to have good seed years if you're dealing with species that have variable seed production? Are you going to have a drought that's going to kill a lot of those seedlings? You know, what's going to happen? There's always uncertainty. Whether it be an invasion of some sort of competing species, how much treatment are we going to have to do of vegetative competition? There could be uncertainty. In red pine, which would normally be a species that's pretty well suited to the seed tree approach, there's a real concern about the effect of diplodia. Diplodia is a shoot blight that is dropped from the crowns of mature trees onto the foliage of regeneration, or shorter trees, I suppose, and can cause a very high level of mortality. And so there's some real risk associated with having with having mature red pine over red pine regeneration, whether it's planted or of natural origin. Those are that uncertainty and diplodia risk in the case of red pine are two factors that constrain it. And it's also just a little bit more complex and a little bit of an unknown quantity, I think, for a lot of foresters. But it's an important, it's part of this toolbox and something that we do sometimes see. It's certainly something that forest managers should be aware of as an option. Here's a satellite image of the seed tree treatment that I mentioned earlier here at the Clearcutting Forestry Center. That road on the left is University Road, heading north-south toward the center. Here's a picture from the ground within that same site. As you can see, the seed trees are red pine. It's a little bit tough to see, but you can see the top half of a tree in the foreground. I mentioned earlier the importance of wind-firm trees, so we want our seed trees to have large crowns so they'll produce a lot of seed, and they do need to be wind-firm. You can see that you may be able to see in this picture that a couple of these trees weren't quite wind-firm enough, and a few of these seed trees have blown over. Not at all an uncommon situation, and again, one more source of uncertainty. I mean, if you're relying on these trees to produce the regeneration, to produce the seed, to regenerate the stand, and you lose them all to a windstorm, well, you better have a good plan B. So this brings us all the way over to the right-hand end of our spectrum of harvest intensities, the clearcutting method. And this is the one that I think is most commonly kind of misunderstood as simply a harvest method and not a whole silvicultural system. Clearcutting is another even-aged system favoring shade intolerance or light-demanding species. In its simplest form, basically all trees within the harvest area are removed. In practical application, certainly here in Minnesota with the guidelines and concerns about wildlife and other things, it's very common to see residual trees left within a clear cut, sometimes scattered, sometimes clumped. And this is by far the predominant system in Minnesota. So clear cutting is applied far more frequently than any of the other systems that we've heard about. Most of us know what a clear cut looks like. Here's a picture again from Wisconsin. Oh, and I guess I pulled out some pictures, but I guess I didn't put them in. But again, we all know roughly what a clear cut looks like. I'm going to pause here for questions. Again, any questions from, about any of those systems? Julie's shaking her head, so if you do have any other questions, feel free to type those in at any time. But for now, I'll keep moving. So intermediate treatments. We've already talked about the four methods that we see at the lower right here. Now let's add in intermediate treatments. So a silvicultural system, as I said at the beginning, involves these three key kind of processes or steps: regenerating the stand, intermediate treatments or tending to that vegetation after it's established, and then the final harvest. And I'm not going to talk about all of these, but we see four different intermediate treatments listed here on the right side of the screen. Release, well, I mentioned the release, releasing the vegetation in a shelterwood. Pruning, thinning, various kinds of intermediate cuts can all be considered intermediate treatments. The big kind of difference between an intermediate treatment and a harvest is the intent. An intermediate treatment certainly can be commercial, meaning that it generates net revenue, but the intent of an intermediate treatment is to improve the quality or productivity or growth or whatever it is, however you define quality or productivity of that stand, rather than to regenerate the stand. So some thinnings look an awful lot like some silviculture or some shelterwood treatments, and it can be hard visually to tell them apart. The way you would tell them apart is that primary intent. Is it to improve the stand, improve the trees that are left standing, or is it to start over? There are all kinds of different names or different approaches for intermediate treatments. Timber stand improvement or woodland stand improvement is a very broad term designed to, as the name suggests, to improve the stand. Again, however you define that. Stand improvement for some landowners that I've worked with over the years has involved leaving all of the den trees, which would make some other people think they're crazy, but that's not going to produce timber. So if you're just thinking about timber, you probably wouldn't want to do that. But if you're thinking about wildlife and you want to have den sites or nest sites for various kinds of species, that might make a lot of sense. You might not care much about form. If you don't care about timber, you probably don't care a lot about form, but you might want trees with big crowns to produce mast, acorns, hickory nuts, walnuts, and so on. So quality or improvement is kind of in the eye of the beholder, but TSI treatments are one kind of intermediate treatment designed to improve the stand. Thinnings can be pre-commercial, which means they cost you money or you can't make money on them, or commercial, meaning they generate net revenue. Intermediate treatments can also be salvage or sanitation cuts. Salvage harvests are designed to salvage value from a stand that's either been damaged or is undergoing some sort of forest health problem. Sanitation cutting is designed to remove generally forest health problems before they can expand and impact more of the stand. So again, there's a wide variety. I don't have time to go into all of them, but a wide variety of different intermediate treatments that could be done. One of the really common ones is row thinning or mechanical thinning that we see here in Minnesota. This is a red pine stand, I think in Mora. You can see a common problem associated with this, which is profuse growth of understory shrubs, in this case hazelbrush. But row thinnings and other kinds of thinnings in red pine can really dramatically improve growth of that stand and improve forest health and so on. Timber stand improvement is kind of illustrated here. The focus of this particular treatment depicted here is on improving overall form of the stand, so not mass producing or dens or whatever, as I said before in the other example, but here the worst formed trees are removed, the best formed trees are retained, and we end up with a stand in which each of the residual trees has a little bit more room to grow, a little bit more growing space. Growth rates, stand vigor, forest health, and so on will likely improve, and we have an improved stand. Another way of showing this, this is kind of a before and after, and I should have proper attribution on this. This is from a general technical report, and I don't remember the title of it right now, and I don't want to get it wrong, but sorry about that. This is a crop tree before release on the left, and a crop tree after. The crop tree approach is another intermediate treatment type focused on identifying basically the best of the best trees in there. They could be very small, they don't have to be big, and then creating growing space around them by removing competing trees. You could have a lot of crop trees or just a few per acre depending on the treatment, but it's very focused on again finding the best trees and giving them more room to grow. And you can see that growing space in the picture here on the left. The crown of that tree has a ton of room for expansion. And then there are just a ton of variations on these themes. So I've gone through kind of the theoretical sort of ideal versions of each of these systems, but in practice things are often done very differently, either in combinations of these different approaches or in other ways. We hear more and more these days about an approach called variable density thinning, in which thinning occurs kind of throughout the stand, but maybe there might be kind of gaps, kind of higher density thinning, more trees removed in some areas, fewer trees removed in other areas, some areas left entirely intact, and so on, to provide more complexity, more structure, and diversity within that stand. Clearcutting or other treatments with reserves. We might have reserve patches. That's a very important guideline that's recommended in Minnesota's forest management guidelines related to leaf trees. And so we see a lot of silvicultural treatments, perhaps more now than in the past, that intentionally include leaf trees as part of that harvest area. And there are just a ton of other variations and ways that these different tools can be brought to bear in the woods. And those variations really are where the art that we heard about in the definition comes to play. So I was going to do some sort of a quiz, but I don't think I'm going to do that. So what's this? This thing doesn't really fit very well. This is the cover image that I used for the webinar and for the workshop that's coming up. I don't know, parts of this look like a seed tree, parts of this look like sort of a negative group selection harvest. This might be a seed tree harvest with reserve patches. Sometimes it's tough to name these things. There might be a polka dotted boot if you prefer that. I don't know. But you can see, treatments like this really do create a fair bit more diversity within that harvest area. Diversity of conditions, some very high light conditions throughout the matrix, some largely intact, untouched patches throughout that might provide refugia for different plant or animal or fungal or other species, and a real mix across that harvest area. This is a picture that we may visit, a picture of a stand that we may visit during the March workshop. This is an aspen clear cut that had a red pine stand kind of coming out into the middle of it. And this is definitely a clear cut, not very large, just a few acres. Another kind of trend we see, generally smaller harvest areas in Minnesota in the last several decades, with a number of residual red pine trees. There was a desire to maintain or retain this red pine component on the site. And so, again, even though we see a clear cut, and even though I said earlier that clear cutting means removing all the trees, in practice that rarely, or it doesn't happen all the time. This is a satellite image showing that same stand. And, you know, we can see, it might be a little bit tough to see, but kind of down in the lower center part of the stand, we have a little wetland here, a non-open water wetland with a riparian management zone around it, buffer of intact vegetation. These trees, if this shows up, the red pines that we saw earlier are in a line kind of coming out here. And we, you know, I said before, the guidelines recommend leaving leaf trees in a variety of configurations. Recommended that they generally be clumped, but sometimes they're scattered depending on what you have to work with and so on. And so we see more and more clear cuts like this than what we think of perhaps as kind of a large-scale, wide-open clear cut. So I mentioned earlier that I was going to talk a little bit about data. So is this done in Minnesota? What do we actually see done? Again, I hope you can read this. This is data presented in a publication by Tony D'Amato and a number of collaborators from 2009, so it's a few years old, but not too old, and it's generally consistent with other similar data. So this is statewide. This is not for any one landowner. And if you look at clear cutting, I think the number here is about 80%. Now that does include a couple of different variations, different types of clear cuts, which I'm not going to go into, but let's say 85% of harvests in Minnesota in 2009. This is based not on aerial surveys or whatever, but this is based on survey results. Best estimates of the representatives of the number of landowners estimated about something like 80% of the wood harvested on their lands was clear cut. Shelterwood, very small percentage. Seed tree is that little orange slice, very small percentage, 2 or 3% in each of those. Selection, maybe 5 or 8%. Thinnings form a larger component, might be 15 or 20%. But the vast majority of the harvesting in Minnesota is clear-cut harvesting, clear-cut silviculture designed to favor light-demanding species. So we got about 5 minutes left. Again, any questions? I'm happy to take questions at the end here, but I'll go through a few closing thoughts and try to wrap up on time. So I started by defining silviculture in a couple of different ways. The art and science of manipulating vegetation to achieve a variety of values and desired conditions. I also defined it as applied ecology that's really driven by human values. So we very often have differing opinions or different views about what would be the best thing to do for this stand. What should the future condition be of this particular stand or of all of the forests across our landscape or whatever it may be. Again, I described it as an art and a science, and I told you about some kind of idealized or sort of theoretical versions of a number of silvicultural systems. In practice, things are rarely deployed in a manner that's exactly like that. In practice, it's far more often some variation of these different tools across the harvest area or so on. And I talked about trade-offs and the differing views that's whether it's based on differences of opinion, whether it's based on best management practices to preserve the quality and productivity of the site, whether it's based on cost, operational possibility or efficiency, human resources and time that it takes to set up more complex sales or other things. There are always trade-offs inherent in our silvicultural treatment and forest management. couple of other quick thoughts, and I have seen a couple of questions coming in, so I will leave time for those. Silviculture is really very local. What works in one place may not work the same elsewhere. There are differences in silvics among species, differences in the moisture environment, presence or absence of other competing vegetation, and so on. And so really silviculture involves a high level of experimentation. And I think I managed to forget to put in a link to the Great Lakes Silviculture Library. We'll see if I put that in. I'm not sure if I did. If you're interested, we've got about 40 or 45 cases, actual real-world silviculture cases from across the Great Lakes on the Silviculture Library website. Those are all public and free and available. If you want to see how are people managing red pine across the Great Lakes, across the lake states, or any other species, you can take a look at that. I've already gone through some of these other considerations: markets, operations, human resources, time available to set up all these sales. Certification. Many of Minnesota's large landowners, both public and private, are certified, third-party certified, and certification imposes some requirements for landowners to follow in their management. And you can see on screen here a cover shot of the forest management guidelines that guide a lot of what happens in our woods. That's the end of my talk. I would be happy to take questions. I know we've got a couple, and feel free to type others in. Yeah.
If you lose all your seed trees to a windstorm, what do you suggest for regeneration?
Planting, I suppose. You need to have some source of regeneration in order to get regeneration, depending on the configuration of that stand and what's present. If you have it's a long, narrow stand and you have the option of, or the possibility of wind blowing in from one side, that might be an option. But really you need to get regeneration established very quickly, or else you'll get something else established that'll have to compete with. And so either direct seeding combined with some sort of site prep or planting would be the most likely options.
What is a typical stand size for clear cuts in Minnesota?
Oh, I wish, as I was preparing this, I was thinking I wish I had looked that up, because I know I've heard the statistic a couple of times. Oh, actually, I guess I do. Well, I'm probably going to say something that's wrong, but I think when I was looking at the D'Amato publication a little bit ago, I think the average clear cut size was 25 acres or so. That seems big to me. I actually thought the number was going to be smaller than that. I'm getting funny looks from the crowd here in Cloquet, so I don't know if I'm high, low, or just off in general, but relatively small. And I'd be happy to look into that and provide a better answer later. Any other questions?
A few more.
Oh, good.
Are there certain silvicultural treatments that are limited to certain sites? For example, do riparian bottomland hardwood forests demand one or two silvicultural practices?
No, I wouldn't say that. I mean, certainly that there are different treatments that are more conducive or that are better suited to particular species. I mean, that's very true. If you want to grow aspen, you're not going to grow it using the Shelterwood system or group selection unless you use very large groups. And likewise for red pine, in part because of diplodia and other risks that I mentioned earlier, and so on. Riparian bottomland hardwoods is a system that I don't have much experience with. I think it's, but I can say, I guess, that there wouldn't generally be only a single approach. Really, the right approach depends on the size of how much land you have, what your objectives are, what you're trying to regenerate, and so on.
How about agroforestry? Where does this fit into silviculture?
Well, there are infinite variations. Have I mentioned that? There is some really interesting stuff happening with agroforestry, a little bit more attention to approaches like alley cropping and various growing various kinds of non-traditional forest products or non-timber forest products, forest farming, using the canopy to create light conditions suitable for production of various kinds of medicinal herbs or other kinds of things. So agroforestry just introduces a whole other set of tools that relate very strongly to the kinds of things that I've talked about, but are a little bit more focused on mixed ag and forest systems.
Someone asked early in the presentation if doing nothing was a silvicultural technique.
Yeah, thank you.
Could you comment on no harvest?
Yeah, certainly no harvest is an option. I mean, you know, if we define a silvicultural treatment or a silvicultural method as a method involving regeneration, intermediate treatments, and final harvest, then, you know, deciding this year or this decade or, you know, for the cycle of this next management plan that we're not going to harvest could fit into any silvicultural system. No management is always a management option, and one that can be very suitable depending on landowner objectives. So doing nothing ever, I don't think would generally be defined as a silvicultural system, but doing nothing for a while is a completely valid and sensible management approach. You know, ultimately, if you were trying to define what system is being used on a parcel in which, you know, do nothing is the near-term objective, you'd have to know a little bit more, or at least have some idea of what you might do out into the future. Trees don't live forever, and of course, you know, species replace one another and so on, but you'd want to know in the longer term kind of what's the intent. Is that it?
There are a couple more. Do you have time?
Yes, sure.
Okay. Is the lack of other methods other than clear cutting mainly a function of cost and difficulty, or a forester's resistance to trying alternative silvicultural methods too?
Well, I've never interviewed foresters to determine that. I think that that's a question with maybe a complicated answer, and I sure wouldn't want to speak for the owners and managers of all those acres. So I'm not going to respond too much there. I will say that, you know, a big part of Minnesota's natural disturbance history is large-scale fires. And so one big factor driving the use of large-scale, high-intensity disturbances is the desire to emulate those disturbance patterns historically. The species that are maybe most important economically in Minnesota, aspen is far and away the most important commercial species. It's shade intolerant and basically can only be regenerated commercial. You know, if you're trying to produce aspen timber, you clear cut. The same is mostly true of red pine, in part because of displodia and other risks that I said earlier. So those species are generally managed using clear cutting, and that's a big factor. The other things that the questioner mentioned might play in. I don't know, but those are the big ones, I think. And by the way, I will say, sorry, Julie, but we are a minute or two after 1 o'clock, so if anyone, of course, if you need to move on, you're not going to hurt our feelings if you sign off, but I'll stick around until our questions are answered. Yeah.
More of a comment. Paul Dubuque has weighed in from the DNR to say that recent clear-cut size on state-administered lands is around 25 acres.
Yeah.
And that comes from data from 2012 to 2014.
Thank you, Paul. So I wasn't too far off the mark with that, at least on state lands.
And kind of a general question, what is the role of fertilization?
Oh, goodness. I don't hear much about fertilization in Minnesota. Are you just raising your hand? Yeah, okay. Yeah, I think it's very rare to be done here. In other parts of the country, I know in the southern U.S., and maybe in other parts of the world, it's done more commonly, but it's really not. You don't hear much about it here. Is that it? All right, great. Well, with that, I'll thank everyone for tuning in. This has been fun. If you like what you heard, or if you're interested, consider going to the SFEC website. We'll have a link to the. We do already have a link to the workshop that's coming up on the 24th. We'd love to see you here. That workshop is going to be very similar in content to what we heard here. A little bit more on the applied side, and a lot of field time. We'll be outside for most of the day. So, again, I'm Eli Sagor with SFEC. Thanks to Kyle, Gil, and Marcella Windmuller-Campione who helped to create the presentation. Thanks to Julie for managing IT and questions. And thanks for tuning in. I hope we'll see you next time.